Our topic today is on flowcharting, repetition. I hope that we get a bit of a chance to look at some flowcharting and yeah, a little bit about repetition. So let's get started. You've already seen a bit of flowcharting, I think. We did some bit earlier on. Now, the idea here is an example for you. Supposing you were part of a committee that had to come up with a mascot for the or some kind of marketing campaign for the 2022 World Cup games here in Qatar. You know, maybe they came up with a mascot. I don't know what their mascot is, but if they came up with a Lego mascot, you know, how would they have gone about doing that? How would they have come up with the decisions to do all of that? I hope I'm recording. I'm pretty sure I am, but so the slide that I'm showing you here hopefully would bring some memories to you of what we've been talking about in the last week or so, couple of weeks, is that we would use a process of computational thinking. And some of the things that we do in computational thinking, we have a big problem, which is our mascot problem. We would break that problem down into smaller parts. So there would be some small, a Lego represents smaller parts, I suppose. And then we would notice that there could be some things that are repeated. We'd certainly see that with Lego, where you have 2-pin blocks and you have 4-pin blocks. And so they can be reused over and over again. The abstraction, the idea, we've talked about it many times. How could that be applied to this particular problem? You would remove from your considerations, from your analysis, everything that didn't relate to your problem in the solution of it. So here it talks about things like simplifying the colors, using block colors, as opposed to something more complex. Lastly, you'd come up with a step-by-step sort of solution on how you're going to go about doing that. Salam, I think it's Salam. Is that right? Salman and Hind, I think. So there we are. Now I've got some notes there, and as I've been doing for you in the past, what I want to do is I want to show you the notes, but just make sure that you have a chance to see those, because the notes, I can't really give them to you, but you can see them there. Step-by-step instruction, that's our algorithm. We're going to use one way of showing an algorithm is to use a flowchart. So that's what we're going to look at today. So the flowchart would be the implementation of the step-by-step instructions. And as it says there in the last little point there about when you have your step-by-step instructions like pseudocode or plain English or a flowchart, you should be able to implement it in many different languages. So if it's just instructions on how to do the mascot, somebody in a different language should be able to pick that up and understand and work with the instructions. So it wouldn't matter if it was Arabic or English or Chinese or whatever. So hopefully you remember, this actually is a slide from a previous lecture, I think, where we said, when we're talking about an algorithm can be represented in many ways. Particularly, it can be in plain English. It could be pseudocode, which is a kind of structured English with rules, just for making programs, and a flowchart. And the example here also is the IKEA furniture. IKEA furniture, the instruction set that you get with your IKEA furniture, which is in a flat pack, could be considered to be an algorithm. And it doesn't use any language at all. I mean, it wouldn't matter if you were a Chinese person, a Filipino person, a Arabic person, a German person, or a Swedish person. You'd pick up those instructions and you'd be able to follow them because there's hardly any words in it. It's just numbers and pictures. And, you know, you just follow the pictures, instructions, and everybody can understand those. That's the whole idea of it. And if you think about it, that totally makes sense for a little company in a little country of Sweden. I don't know how many people in Sweden, but it's not a lot, maybe 4 or 5 million people, not much more than in Qatar. And they got their own little language nobody else in the world speaks. So it's not like Qatar where there's 5 million people speak Arabic, but then there's 400 or 500 million other people around the world that speak Arabic. So, you know, Arabic is a bit wider spoken than Swedish. Anybody here know anybody who speaks Swedish? I mean, even the people in Germany don't speak Swedish. And that's just next door, right? So they got this little country, not many people. They speak Swedish. They're not going to be writing the instructions in Swedish and making a big export industry, are they? Because nobody's going to be able to read it except the Swedish people. Yeah. Full disclosure, my grand from Sweden. My surname Floden is a Swedish name. Just maybe that's why I talk about Sweden a bit. I don't know, maybe. Anyway, so flowchart. We have some special symbols there, which you're familiar with. We're going to see these symbols a little bit more close up in a minute. So yeah, it's a diagram which represents a set of instructions. The thing about the flowchart is that you should be able to look at it, not just you, but that Swedish person, that German person, that that Chinese person can look at the flowchart and fairly easily sort of understand what's going on there just by the shapes. All right, so this shape means there's a process. This shape means there's a decision. This shape means there's a start or an end, that type of thing. Now, maybe there may be, yeah, the level. There's a few notes there in the slide about the level of detail. Remember, when you're doing abstracting, you can abstract to a level of detail which is too detailed, and then maybe you need to sort of oh, well, too detailed is what you expect at the start, but you could abstract down so there's not enough detail, and so then you have to sort of back up a bit. If you abstracted so far that you didn't have enough detail, your flowchart would be too simple, and you know, not really making much sense. If it was too detailed, then there would be too many steps in it. Maybe you wouldn't be able to fit it onto a page. So here's a simple flowchart, which I hope that you would look at. And even though you haven't been doing computing for very long, you'd be able to understand this flowchart, correct? Can you see where you start? Okay, so there actually is a symbol there that represents starting, right? This symbol here represents either a start or an end. We see the arrow coming out of it, so it's probably the start. And we see one here, which is the end, which is the same kind of symbol. So I guess you get the idea how it would work, right? Who can tell me what's happening here? People at home can't see that, but what I'm saying is, who can tell me what's happening here? Yeah, it's a decision. So this could be represented in a program by an if then else. If then else, if it's before 7 a.m., then we go and do this. We take the metro. Else we take a taxi because the metro won't get us there in time. Yes, very good. We'd take a taxi if it was before, if it was after 7. Otherwise, we'd. So that's a if then else. If then is the yes, else is the no. So else is always going to be the false of that structure. So this little page here just represents the symbols and what they might mean. This is a very simplest version of the symbols. So you've got a start or stop. I've also referred to that as a connector because you could use that to say go to the next page, or you could use that to say continued from the previous page. Process is going to have square angles on the corners. Decision is going to be your diamond. The diamond is going to have one arrow coming into it and 2 arrows coming out. The input output looks like a process, except the angles are not 90 degrees. And then you have a direction of flow arrow, which gives you an idea of what process happens after the next process. It gives you the sequence, what happens next. So here's another one. This would be a process that somebody at the mall would use when somebody comes to the front door of the mall, right? So here's a process. They will greet the customer. Then they'll ask them to show their address. Now, notice this. The angles are not 90 degrees. This is representing an input. So what this would mean is, this really means, you know, input. What is the address? Is it green or red or yellow? And if it's green, then we're going to we're going to say to them, this is an output. We're going to say, welcome. And if it's not, we're going to say, sorry, you can't come in. And so that's that process. And I'm not really a fan of the Big Bang Theory, but it's on TV. Maybe some of you guys know it. So when I say it's on TV, it would be on one of those channels that you could watch, you know, American stuff, I guess. My kids are a bit more of it. They're way younger than me. But what's interesting in here that we haven't seen before is we have some special symbols that we haven't seen. So we got this one here. It just looks like a, I'm actually pointing to it with the cursor at the moment. Phone call, place phone call. What we've got is we got two parallel lines on the edges of it. So that means that it's a process, but it's a process which is detailed enough that we would go and write another flow chart for it, I suppose. So this is a process with more than one step in it, multiple steps in that process, which need to be detailed as well. And so that process will become a function. It will become a function when we implement this as a program. So that's what that means there. It's going to be a function, or you could call it a submodule or a subroutine. Okay, so it's a new module on its own. Somewhere in our diagram, we would have a diagram which just represents what's going on in this box. This box here is just looks like a black box. We can't see into it, but somewhere we would have to describe what's going on there because there's more than one thing, right? Apparently placing a phone call is a bit more than one thing. I don't know. It doesn't seem like a lot to me, but maybe. The other thing I noticed in this diagram, we don't have any colors in the boxes. That's important and cool at the same time because the colors are not really important. They don't really have any meaning to them. So you might see flow charts and they have colors in the boxes. You might assign them, but just as a default, there's no real meaning to the color that is implied just by you having a flow chart. There's no need to put colors in it. We haven't put any colors. The other thing is we've had to do some other implications here because we should have coming out of every decision box, and here's a decision box. You should have two arrows coming out. This one does have two arrows coming out. One should be labeled true and the other one false, or yes, no. They mean the same thing, right? Yes means true, no means false, true, false, whatever. But here we haven't actually labeled the yes, but I suppose you could figure that out anyways because it's not no. This one must, since this one's no, that must be yes, right? So we've got that. We've also got multiple inputs going on throughout the thing. All right, so socially awkward, really smart guy. That's what this is referring to. Really smart guy. He's like a physicist or something, you know. So I mean, you know, he finds it kind of difficult to get become friends with other people because he doesn't have the patience, you know, because everybody's kind of slow compared to him, like he's working at warp speed or something, right? Yeah, you know what I'm talking about. He's really a smart guy, right? And so he doesn't have a lot of friends, but he's still a young person, and young people tend to like to have friends. And so he has this set of processes where he will try and make friends with people. And so that's what this is about. So he'll call somebody up if they're home. If they're yes, he'll ask them if they like to share a meal. And if they say yes, then he'll ask them, and then they'll dine together. And we see a whole process there. And this is good for the whole process because you see the double lines, right? Indicating that there's a lot more going on there, right? And dining together. Yeah, that's a big deal, right? You know, where are we going to meet? You know, what time we're going to meet, what you're going to eat. There's a big thing going on when you dine together. And then maybe when you dine together, you become friends. Awesome. But more likely, he's going to ask them if they want to share a meal, and they're going to say no. And then he's going to ask them, you know, well, you don't want to share a meal. Would you like to have some caffeine, some coffee? And then maybe we could meet together and we have a coffee, do the same thing. You don't like that? Okay. Well, maybe we have some shared interest. Maybe you like to skateboard or something like that, or play basketball. Yeah. Anyways. And if not, then we kind of run out of ideas. It's just a joke kind of flow chart. Okay. You get the idea. Nobody's going to write a program to do this. But you know, maybe you could relate to it. And that's why it says just for fun. That's a fun for fun thing. I don't know. Do you guys watch that Big Bang Theory? And me either. Yes, only smart people watch it, like Joshua. don't watch it. My kids watch it. Yeah. All right. So here's a simple flow chart. And so what do we got going on in here? Somebody wants to know what is their grade. And so what we're going to do is we're going to get some grades. All right. So we get 3 different grades. We get a grade for a quiz, we get a grade for an assignment, and we get a grade for a test. We add them together, divide by 3, and we got the average. Seems fine. The only problem that there would be with this is the average would be that there would be an even weighting of all of those different grades, right? So if you just took those 3 grades, divided them by 3, then each of those grades would be worth 33% of the mark, 33.3% of the mark, right? Because 100 divided by 3 is 33.3. And that's what we did. We took three marks, divided by 3. But when we go and we look at our course outline, we'd say, oh, wait a minute. You know what? So I don't know, this is not our course outline, it's somebody else's. But the assignment is actually worth 20%. The quiz is worth 30%. And the test is worth 50%. So an average is not really going to work here. We're going to have to do a weighted average. We'd call it a weighted average. So we're going to weight it. So what we would do is we'd say, okay, what's your assignment grade? What's your quiz grade? What's your test grade? We're going to take the assignment grade, multiply it by 20% or 0.2. The quiz grade, multiply it by 30% or 0.3. And the test grade, multiply it by 50% or 0.5, add them together, and there's your grade. It's kind of like an average grade. It's still going to be out of 100, but it's better. It's more precise. You know what I mean by precise? It's more closer to what we're kind of looking at. Accurate would mean close to what we want, but precise has to deal with how close it is. Accurate has to do with how correct it is. So yeah, this is more precise and accurate. So that's probably what we would do. Could we? Oh, right. So this is a different one. What if we were to draw a flow chart, which would be a step process for accessing the course syllabus on D2L? You want to access the course syllabus on D2L. So you would go and probably log into D2L, then you'd go and find it somehow, right? Maybe if you're, depending on how familiar you are with D2L, you'd know that you could do this in 3 or 4 steps. So, so you'd log in, I guess. Let's just see the process, right? You'd go to D2L and you say, I want to know where is the, what was it? The course outline or something like that. So I could go to course home. Maybe that would be a good place to start. Somebody's trying to chat with me. Take subway. Yeah. All right. So, I want to know where the course outline is. I think I would go to one of these things here. They would look like these would be a good place to start, either content or course. We're at course home. That's not very helpful. So I go to content. I'd click on content and then see if I could see it there. Well, look, I got an index here, and there's a thing there called general and table of contents. They might be helpful. So if I went to general, oh, was it course schedule? Would that help? If I went to general, there's a course syllabus under general. So now what you have to do when you do a tutorial is you need a drawing tool. And so you could use Microsoft Visio. I recommend that. That's a nice one. But that only works if you have it, if you paid for it and have it, right? I think there it is on some of our computers here. But on the other hand, you could use something in the cloud. You probably know that there's all kinds of applications in the cloud nowadays, right? So this is a free one, which is called apps.diagrams.net. apps.diagrams.net. And you will need to specify a place where you're going to save your work. So most of you have a OneDrive account. If you have a Microsoft account, you have a OneDrive account. So I've got one. So I'm going to say, well, I'm going to use that and I'm going to authorize it. So it's actually going to require me to log in. As long as I've logged in on this computer, I'll be okay. Yeah, I have. So I'm going to create a new diagram. And what's really cool about this, as I said, totally free. You can use this totally free. You have lots of different diagrams you can choose. I'm going to choose a blank diagram, I guess. Create a blank diagram. Use a root folder. Yeah, okay. And then what I'll need once I've chosen my diagram is I'm going to need some tools to work with. Now, there's a bunch of tools there. But what you could do is look, there's general tools, see if you can see anything like flowchart, flowchart tools. And so now, you know, those flowchart tools are kind of old style flowchart tools, but yeah, okay. But we have diamonds, and okay. So we got to start, we got to end. Yeah, so what was the thing we're going to try and find? When I double click on it, I can just type start. Try and spell it right. And you can change the size and the shape of it, right, to make it fit how you like. You guys are going to be way better than this than I am, I'm sure. And then what was it? I would open D2L. So that would be a process. Don't get too fancy with these things here. Just find a nice square process or something like that. Now, when I say it does come up as a square, that's fine. And look, it says it's a process. So I'm just going to say open D2L. But you'll notice that the way we've been doing it, excuse me, it seems I have my caps lock on. Open D2L. I can't spell for beans, can I? How's that? Open D2L, yeah, that's fine. Now, I don't like the shape of that. Doesn't look like anything like we've done before, but that's looking a bit better. And then I need to actually put those together. So I need to have a line. So here's a line over here. Yeah, that's fine. But the line should have an arrow on the end. Edit style, maybe. Around. Thank you. On the left side, you can, no, I don't like that arrow. Up here. Where? Basic? Where's arrows? Where? Down? No, up. Oh, there. Yeah, sorry. I don't like those. No. I want a line. Sorry? I'm going to try this. Yeah, like this. It will give you all right. So, okay, because I've highlighted that already. So click and change it anyway. So that's fine. Except they're the wrong, it's pointing the wrong way. Anyways, it's two-headed arrow. And delete it. I mean, there we go. So I got my arrow. You guys could do that better than I could, as I said. So to play around with that, we're going to open D2L. You know what I'm going to do with that is I'm going to copy it and I'm going to paste it. And I'm going to call it down here. And after opening D2L, what will I do? Open D2L, navigate to, I don't need any choices, do I? So navigate to D2, navigate to the, what's that menu? Main menu. And then I'm going to copy that again. Control C, Control V. And after I navigate to the main menu, I'm going to actually navigate to the content. And then I'm going to open. Then open. So I'm not having any choices here. So this one's just going to be open. What is it? It's course outline. It's just like that. And then I'm finished, right? So I'm going to take that, copy that, and undo that. I got to yeah, just escape, right? Oh, well. I just need to stretch it out a bit. So it's not going to be a start. It's going to be an end or finish or something like that. If it starts, it's probably going to be finish. And then I can do the same with the arrows to join it all up, right? Now, suppose I could take that arrow and copy it 10 times or something like that. Copy, paste, right? Look at that arrow going through there. Yeah, you get the idea, right? Oh, sorry. I don't claim to be an expert in sort of drawing tools, but the point that I'm trying to make is it's kind of easy. I think you could probably do it, right? If old guy up here who hasn't done it for a long time can do it in a couple minutes, you could probably do it in half the time. So there you go. You got a flow chart. Pretty easy, right? And put your name on it. And there we go. There's our flow chart. Kind of cool. You can do that, I'm pretty sure. So that's the tool that I would recommend. But as I said, you could use Visio as well. All right. So what about our algorithms? The flow chart is a representation of an algorithm. When we go and we look at that flow chart, that represents step-by-steps on how to do things. We could have done it in pseudocode. We did it in a flow chart, and that's not a problem at all. We could do that. Look at that. You got lots of tools here. Looks like you could draw flow charts in PowerPoint. Somebody might try and do that. I don't know. This slide has shown up before as well. And so I just want to remind you of what we talked about in this slide when we did. We mentioned that flowcharts, of course, have instructions, and the instructions we have as our processes. They have decisions in them, etc. Programming constructs. That the decision helps us to do the construct, right? Because besides one step after another, we can choose and we can branch. And then branching allows us to do iteration to bring things around. They should have an endpoint. Algorithms should be correct and they should be efficient. We talked about that a little bit, and I think I even mentioned the big O. The big O will be used when you get a bit further on, if you decide to sort of get into the computer science of things, which is a measure of the efficiency of a algorithm for a module, the big O. So that becomes important when you start doing sorting and searching and things like that. It can be very efficient or it can be very inefficient. Here's an example of something where the efficiency of a computer comes in pretty handy. We could have a very, very inefficient sort of algorithm to do this. This is the punishment problem. The student did something which annoyed the teacher, and the teacher said, write this out 100 times, something like that. I don't know if that ever happens. Apparently, I don't know, never happened to me. Apparently it happens, but so if we're going to do that, it would take a long time to write things out 100 times, right? But if we had a computer to help us, we could just write it once and tell the computer to repeat it 100 times, right? That's the efficiency of a computer. That would work really nice. Just a bit more, we'll get back to that. We're going to look at some of those algorithms in a minute. Running out of time. We got 9-10 minutes left, I think. So these three things here are important in our algorithm: sequence, repetition, and selection. Repetition and selection kind of go together. You can't really do selection without doing, you can't really do repetition without doing some kind of selection. The repetition is going to have a condition in it. It'll repeat until. So the condition will be like a decision, okay? And so you'll see that in your flow charts. When you try and do a repeated action, you'll see that there must be a decision in there somewhere to make that repeated action happen. So that's what I mean by repetition. The same bit of code is repeated over and over again. That can only happen if you have a condition to allow that to happen. We'll look at that in a second. Here's an example. I will not cheat on assignments. You have to do that 100 times. That would take you a long time to write that out. You could do it like this. Boring. Or you could, as you say, get the computer to do it for you. So instead of having to say, I will not do this 100 times, maybe you could put it into a loop. And so the loop will say, I will not cheat. I will keep on doing, I will not cheat until whatever. You've reached however many times you had to say, I will not cheat. All right, so how would that look? This is the flow chart, so I'm not going to draw it again. It's missing something. There should be a decision box right here, which sort of says, is the count 10? And no, we'll go back and do it again. Yes, finished. Okay, so there's missing a little little box there. I just want to show you, you could implement that in a computer program. I want to show you computer programs because you're going to be doing that soon. You don't have to do this. Oh, sorry, it'd be good if I spelled idle correctly, right? LE. Now I put it in the wrong place. I'm not supposed to be searching for it on the internet. I'm supposed to be searching for it on here. Sorry. There it is, Python. So, I mean, you can go to python.org and download the latest version of idle. When you run it, it looks like that. And how Python, can you see that? Yeah, I guess you can. So how Python works, can you see that? It's not too small. Let's see what size. Yeah, 16. 16 is probably pretty good. That's about as good as we're going to get. So this is the not cheat. So let's say we wanted to say, I won't cheat. I'm going to just put a count there, and I'm going to say, while the count is less than whatever, how many times do you want to say I don't want to cheat? 10. I'm just going to say, nobody here cheats. I don't know. I hate that word. I mean, is that right? Count takes the value of count plus 1. Make sure you spell that right. And that's it. I mean, this is now going to print for me 10 times. I will not cheat. Not yet. I have to save it. And it says I got an arrow. While what? Well, count is less than 10. So I will not cheat. That's 10 times. So, really, I don't know if that's 10 times. You could be sure that it was 10 times by printing the count. So I could put the count in here. So here I'm printing, I will not cheat, and then the count. Let's run it. Yeah, okay. So the problem is there, you're saying, well, I'm counting 0. No problem. Just say count plus 1. Run it. There you go. I'm going to say, I will not cheat 10 times, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's not so impressive. You say, I probably could have written out, I will not cheat 10 times as fast as you wrote that computer program. Maybe you could have. So, but could you have done it 100 times as fast as I wrote the computer program? Or 1,000 times? So now you see the power of the computer, right? So I can change that from 100 to 1,000 with one keystroke, right? Could you write that out of it? So that's the power of the computer. We got like 4 lines of code, and I will not cheat 1,000 times. So that's going to get me out of detention for like a whole month, right? Get the idea? So yeah, 4 lines of code. That's the power of iteration. Nice? Yeah, so you would do that. Now, I don't want it to stop ever. I can have a very, very simple program to do that. No count required. But now we're talking 1 line of code, right? While true, no count. 2 lines of code, program that goes forever. Oop. Guys, I should have known that. Got to use a capital. And it'll just go forever, right? Don't know how many times it's going to do it, but a lot. Now you don't believe me on that, I suppose, because it's just stop the screen. So let's put the count back in. And increment the count. Run it again. So yes, it is running forever. Gone past 1,000 yet? No. And it'll just keep running forever. So you can have an unterminating string because there's nothing in there to stop it. Because I just said, well, true. And I got nothing to stop it being true. So I'll have to break out of it with like a Control Z or a Control X. Control X, Control C. There we go. Control C worked. Keyboard interrupt. And yeah, so I don't know. Very simple program. Okay, so like the first hackers, the very simple first hacker program is you would write something like that, and you would ping somebody's IP, sorry, their website with a little program that did this to do a denial of service, and you'd put it in an unending loop. You guys won't do that though. All right, so we're not hackers. That's we don't write programs like that, but we could do a loop. Correct? Think you could do a loop? You could draw a diagram to do a loop. If we're going to do this one, as I said, this would almost work. The problem with this is it needs a diamond right here, which would say 10. And if 10, then finish. Else, go back and do it again. And inside here, we'd have to add 10 to 1. Do we need to draw that diagram? We could do it in our flowchart, but I don't know. Kind of running out of time. I mean, on the PowerPoint. Sorry, thing that. Where is that? So if I went and made a new diagram with a blank diagram, come on. Sorry about this. I mean, it is unknown error. Oh, that's great. Because I keep clicking away at everything. I promise I'm going to finish soon. Oh, maybe if I press that create button and don't touch anything else. There we go. So we're going to have a start. What was this one? This was the 10 times or something. Yeah, we're going to, we need to have a count value. Count takes a value of 0. This is initializing the count. So if you're, once you become a bit more familiar with computer programming, you wouldn't say count, you wouldn't have to say count equals 0. Oh, that's not good. That's not the right emblem, is it? We had one before. It's square. Oh, that's because I'm in general. I'm not in flowchart diagram things, right? So let's go to flowchart. Yeah, so then I can get a process that's better. Yeah, so this would be, we would just